Welcome to our today's class. That is business mathematics and statistics. And for today's class, we're going to talk about the probability theory. Now, when we talk about probability, this is a chance that an event may occur or not occur, or generally an event will happen or not happen. So when we talk about an event, in this case, we're talking about the outcome of a particular experiment. Are we together? That is what we mean when we talk about the probability. Now, what you need to know in this case is number one is what we call the types of events, and on the types of events, we have three types of events in this case. Number one, we have what we call the independent events. Now, independent events in this case are those events that do not influence the outcome of the other event. So, kumaanisha if that other event happens, the other one will not prevent the other one from happening. So, and in this case, for the independent events, in this case, they are normally denoted by the word and. And in that case, if it's the word and, this is whereby we apply the what? Multiplication rule. That is where we apply the multiplication rule. Then number two, we have what we call the dependent events. Dependent events in this case are those events that influence the outcome of the other. Meaning that if one event has to happen, that other one must also must also happen. And therefore, they are normally denoted by the word or, and in this case, this is whereby we apply the addition rule. And then number three, we have what we call the mutually exclusive projects, or mutually exclusive events. These are those events that can happen at the same time. So they are those events that can happen at the same time, meaning that if you choose one event, the other one will not be able to do what? Will not be able to happen. Oh, no, this one for the dependent is denoted by given. And in this case, this is whereby we apply. The dependent events are also known as what? The conditional events. And the conditional events in this case, I've said, are those events that influence each other. If one event has to happen, the other one will have to do what? To happen. Are we together? And for the dependent event in this case, they are denoted by the word given, and this is whereby we use the what? Bayesian rule, or what we call the what? The contingency table. Now, for the mutually exclusive events, I've said is those events that happen at the same time, and in this case, they are normally denoted by the word what? Or. Kumaanisha in this case, these events, if you choose one event, the other one will not have to happen. Are we together? Because the events are serving the same purpose, and therefore, in this case, they are normally denoted by the word or, which in this case, we normally use the addition rule. Those are the types of events that we have on the probability. Then in this case also, the other one that you also need to know is on the rules in probability. Rules in probability, or the rules of probability. Now for the rules of probability, in this case we have number one. Number one rule in this case is what we call the limit rule. When we talk about the limit rule in this case, for a probability is required not to be less than 0, and in this case should also not be more than what? More than 1. That is the limit rule. Kumaanisha ina range from 0 to 1. Sawa sawa. That is the probability. Number 2, we have also what we call in the addition rule. No, before we talk about the addition, let's talk about the total rule. Now, the terms of the probability in this case are required to be equal to what? 1. So, when you add the total of all the probability, in that case, it's supposed to give you 1. So it is not supposed to exceed what? Exceed 1. That is the total rule. Then number 3, we also have what we call the complementary rule. Complementary rule. Now, when we talk about the complementary rule, is that the summation of event not happening plus the event when it is happening is supposed to give you what? 1. Sawa. That is what we mean. Your event it happen, now your event not happening is supposed to give you what? 1. That is the complementary rule, whereby the event probability of event, let's say A happening, and then plus probability of A not happening is supposed to give you what? 1. And that is what we call in the complementary rule. Then the other one, number 4, is now what we call the addition rule. Now for the addition rule in this case, it is applied in the union of events. And in the union of events in this case, we mean if you are given that A, or if they want you to get the probability of A or B, that is where we're talking about the what? Union. Remember, under the set theory, on the set theory, when you are looking for the union of events, in this case, you are getting this, the value of A, you are the values of B. But now in this case, for the addition rule, you will take the probability of A, you add the probability of what? B. And then in that case, after you add that, you will also be required to get the probability of A and B. So that is on the addition rule. A or B, in that case, is probability of A plus probability of B minus the probability of A and what? Probability of A and B. Then the other one, number 5. Number 5 is now what we call the Bayesian rule. And before that, let's talk about the multiplication rule. And I remember we've said for the addition rule is only applicable when you are talking about the mutually what? Exclusive project. And mutually exclusive projects in this case I've said are those events that serve the same purpose. And therefore, if an occurrence of one event, it means that it has to prevent the other event from what? Occurring. Then we have what we call the multiplication rule. Now, multiplication rule is normally applied to handle the independent rules as we said in this regard. And therefore, if you are asked about the probability of A and B, in that case together, probability will be probability of A. You multiply by the probability of what? You multiply by the probability of B. And that is how you get on that area. Then the other one, that is number 6, is what we call the Bayesian rule. Bayesian rule in this case, we've said is not only applicable when you are talking about the dependent projects. And in this case, they are normally denoted by the word what? Given. And therefore, if you are asked about the probability of A given B, probability of A given B, in that case, for you to get that, you just take the probability of A and B, then you divide by probability of what? B. In that case, that is how you will get the what for the Bayesian. So the Bayesian rule. Now, those are the rules in probability. Those are rules in probability. Now, then we also have what we call the probability trees. Probability tree. Probability tree. Now, when we talk about a probability tree, in this case, it's just a diagrammatic representation of an experimental or an experiment and its events. And this we normally consider on two areas. We normally consider on these two types of events, that is the dependent events and also the mutually exclusive events. In this case, the dependent event do not show a certain point, and therefore, but mutually exclusive in this case, they can also be able to show you they can be able to show you a certain point. For independent events, in this case, you say those events, remember, they do not depend on each other. So they can just start from what? They can just start from anywhere. So with that now, we can try some examples in order to understand what we mean in these regards. So let's try this question of the sitting of November 2018. November 2018, question 2C. November 2018, question number 2C. November 2018, question 2C. Now, the probability that a student will pass mathematics examination we've been given there is 2/3. And the probability that he will still fail, in that case, in an English examination, is 5/9. Probability that he will pass at least one examination is 4/5. You are required the probability that the student will pass both mathematics and what? And the English examination. So in this case, the probability that he passes on mathematics, we've been given there as 2/3. Are we together? Then in this case also, if he fails in English, there is probability that he fails in English. So in that case, I can say English not. In that case, is how much? 2/5. And then we also been given there the probability that at least, or the probability that he will pass at least one examination, probability that at least one, we've also been given there as how much? 5/9. So when you get such, no, this is 4/5. Huh? This is 4/5. 4/5. Akianguka English is 5/what? 5/9. And the first one was 2/3. Yes, it's supposed to be that way. So when you get such a question in this case, for you to be able to understand normally how you will get those values, you normally use what we call the probability what? The probability trees. Sawa. So kuna two subjects here. Anaweza fanya hii apite na anguke. Sawa. So in this case, I will have for the mathematics. Remember, in this case, you are using the word and. So what does that mean? Is it an independent event or a dependent event? Yeah, they are denoted by the word and therefore in this case, umeambiwa, if one says that and the probability, it fails. In that case, that is what we call in the what? An independent event. And an independent event in this case, we have said it is not having any what? Starting point. So if you can start from anywhere. So in that case, if it fails or if passes mathematics, let's say it is M. If fails mathematics, let's say is what? M1. So if it passes in English, we can talk of it E. If it fails is what? E1. Sawa. Kumaanisha alipita mathematics, akapita English. Sawa. Kumaanisha hapa alipita mathematics, then akaanguka in what? English. Sawa. Alianguka mathematics here, and then akapita nini? Akapita in English, but also akaanguka in what? Zote mbili. That is how you will now be able to do what? To get that. We say for this case, for independent events, they do not have any starting what? Point. So when you check on this case, the probability that he passes on the mathematics is 2 over what? 3, sindio? Kumaanisha akianguka itakuwa ngapi? Remember under the total rule. Or generally you can also use the other one which we said is the complementary what? Rule. Kumaanisha if in this case he passes on this, ana akianguka the total inafaa kukupea nini? 1. Sawa. So in this case, if he fails here, it will be what? 1 over 3. Sawa. Are we together? Then in this case, we've also been given there, if the probability in this case he fails on English, we've been given as 5 over what? This one will be kuanguka 5 over, maanisha hii ni 4 over 9. Sindio? Are we together? And then the other one is, if he fails on mathematics, or this one also will remain 4 over 9, and also 5 over 9. Sawa. Are we together? Now, probability at least, the probability that he will at least pass, he will pass at least one examination is 4 over what? 5. Sawa. At least one examination. So hii inafaa kulai wapi? Anaanguka moja na anapita, yani anapita more than 3 what? The 2 units. Hizi ni mbili. So akipita zote ama akipita moja. Are we together? So which will be which one? So ukiangalia M1 and the M and E, hapo ni kumaanisha alipita. Sawa. In this one, M1, in this case ni kumaanisha alipita nini? Moja tu, sindio? Hapa alipita moja, akaanguka moja. Hapa alianguka zote. So in that case, this one you are not to apply there. The question was asking the probability that the student will pass both mathematics and what? So atapita wapi? Sini na hii. So in that case, it will be probability of M and what? Sindio? Both. Sindio? Sini M and B. So in that case, itakuja ngapi? 2 over 3. And when we use the word and, that is where we say to use which group? Multiplication. Sawa. So in that case, you multiply by 4 over. So inakupea ngapi? This is 8 over 27. And that is what you are required to do on that area. That is how you are required to get on the same. Now the other one, the other question on the same is on the sitting of, other question we try on the same is now on the sitting of May 2017. Question number May 2017. Question number Question number, we can have question number 3B, May 2017. Question 3B, May 2017. Question number 3B, May 2017, question 3B, May 2017, question 3B. Now, this is what will be given there, that the probability of A winning a game is 1/2, while the probability of B winning a game is 1/3. However, the probability of having a tie is 1/6, and A and B agree to play a tournament consisting of 3 games. You are required the probability that A wins all the games. Number 2, 2 games are end in a tie, and B wins at least 1 game. B wins at least 1 game. Now, probability of A winning, in this case, we've been given there is 1/2. Probability that B winning, in this case, we've been given as how much? 1/3. Then also we've been given there, however, the probability of having a tie is 1/6. So in this case, probability of A wins and B what? Wins. Sindio, ndo wakuwe ties ni wote wakiwin. Probability of A and B. Sindio, which in that case we've been told is how much? 1/6. And how many games are they playing? 3 games. So still again, you're going to use the what? Probability tree. So in this case, where are we going to start from? From a probability of A winning, probability of A not winning. Sindio, are we together? There is also probability of B winning, probability of B not winning. Sindio, are we together? Kumaanisha if they play the first game, kuna mwenye atawin. Sindio, are we together? The second game, there is also another one who is going to do what? To win the game. Sindio, the third game is either a win or any tie. Sawa. So in this case, what we need to do in this regard, we have for A winning, B not winning. We have B winning, B not what? Winning. Sindio. And then we also have probability of them having a what? A tie. Sindio kweli? That is A winning, and meaning that also this one can also have it that way. These are independent events. So independent events, we said in this case they do not have any certain what points. So in that case, probability of A and B winning, there is also A B not winning. Sindio, wote wawili. Sindio, the having a tie, not having a tie. Same case, having a tie. Not having a what? A tie. Having a tie. Not having a what? A tie. That is where having A and B. Having a tie. Not having a what? A tie. So are we together? So in that case, we'll have here, we've been given there, probability of A winning is a half. Maanisha A not winning will be also half, 1/2. Probability of B winning, we've also been given there, is that B not winning will be 2/3. So it is that 2/3. Then the other one, for them, both of them winning, we have for the having a tie is 1 over what? 1 over 6, sindio? So in this case means that not having a tie, it is 5 over 1 over 6, 5 over 1 over 6, 5 over 1 over 6, 5 over 6. Sawa sawa. Now then you are asked on the question, this is how that is the probability tree. And then you are asked on Roman 1. You have been asked a wins all the what? The games. And the probability of A wins all the game will be where? So it will be the probability of A that is on the A and the what? A and a win wapi? Yeah, is only here, sindio? The A is winning all the game in which area? And a win wapi? Sini tu peke yake. Sini game ya kwanza. So ni kumaanisha itakuwa nini? Because he's only winning that game. Sawa sawa. Yes? B akilose. Where else B is losing? Si hapa B ana lose. Au kuna A ana win hapa. Lakini is either they have a tie or not having a tie. Ndio. So if B akiwin ni kumaanisha B ame lose. Ndio. Then if A loses, B ana win. If in the first game. Ndio. So hapa ndo unaona ya pili tunaenda B ndo ana win. Kienda ya tatu ni them having a what? A tie. So the other one is 2 games end in a what? In a tie. And which are these 2 games that will end in a tie? The games that are ending in a tie is which one? That one? Inasema only 2 games that will end in a what? See this one? Yeah, this one and this one that A is losing. Which is which one? Yeah, this one. Are we together? Kuna ile A ya kwanza alilose, si ndio? Kumaanisha kuna mwenye alishinda. A alishinda hapa, si ndio? Akilose hapa B ndio itakuja kushinda, si ndio? So when you check on this case hapa, the 2 games are going to, this game will end in a tie, but in this case at least B lazima kukue kuna yenye ililose from the previous game. Sindio? So when you check on that case, that is where we have in this, and I'm also having what? So it is the probability of A winning, and then we'll also have the B win, and then probability of what? The B and A and B. So this, and this. At the end of it is when it will now be a win for A, B. See, tunasema at the 2 games being a win, akuwe ameshinda. So ndio ikuwe akuwe ameshinda in this case, we are talking about the 2 ties, is the that game. So ni E, AB, and A what? Yeah, it's supposed to be these ones. When B loses, in this case, we have A. So in that case, it will be probability of 1 over 6 plus the probability of what? 1 over 6 bado plus the probability of what? This one 1 over 6 and also 1 over 6. That is now when we'll also have all of them as a what? As a win. When you check on this and also that one. Sindio? That is when it will be a win. Therefore, in that case, is equals to how much? 4 over, which is 1 over 3. Then the last one is B win at least 1 game. And the B wins at least 1 game is the probability of what? Sindio hii? Hapa ndo ata win? Yeah, pia na hii. So it is 1 over 3 plus, not 1 over 3. This one is winning. Sindio? No. A loses, B wins. So in that case, for the probability of B winning, the B winning itakuwa gani? Maanisha B akiwin, A is going to do what? To lose. Sindio? So B akiwin, A ina lose. And hii tu, this 1/3. Sini, A ali lose, so B akafanya nini? Akawin. That is the probability of 1:3. That is what you are required to do on the SEM. What you are required to do on the SEM. Therefore, we can also try another area. Can also try another question on the SEM. Also try another question on the SEM. Is 2/3. Why is it 2/3? Si inauliza B winning. Yes? Roman 2. Oh, this is 2/3. Oh, yes. 2/3. Now, now we can also try the last question. The last question, I want to do this one for September 2015. September 2015, that is question number 5A. September 2015, that is question number 5A. September 2015, question 5A. Question 5A. A and B. That is question 5A and B. September 2015. Question 5A and B. Now you've been given that an investment analysis collects data on shares and notes whether or not dividends were paid and whether or not the shares increases in price over a certain period. Of all the 112 shares that pay dividends, 78 shares had not increased in price. Of all the 127 shares that had no price increase, 49 shares did not pay dividends. The total number of shares are analyzed as 246. You are required to present this in a Venn diagram. So in this case, you have in the shares. And the shares, there is either you pay the shares to increase the share price, or that is you pay the dividend to increase the share price, or not pay the dividend, you decrease the what? Share price. So in this case, we'll have for the shares, and for the shares, they either increase or no what? No increase. No increase. And in this case, I've said in this case, it will depend with the what? Will depend on the dividend that have been paid. In a dependent dividend, wakilipa dividend in this case, maybe it increase or it cause to increase. So in that case here, I can have the total. This is on the shares, and we have for the dividend. Now they can either pay dividend or not pay dividend. They can either pay dividend and not pay the dividend. Meaning that in this case, we will now be able to get the what? The totals. The totals. Now, let's go to that information. Of all the 112 shares that paid dividend, now the shares that paid dividend, tunaambiwa, the shares that paid dividends, tunaambiwa, 78 shares did not what? Increase in price. So 78 out of the shares that paid dividend, and total of them, they were 100 and what? Sindio? Hizi ni nasema, the shares tinalipwa, and then the dividend is being paid in this regard. Sawa sawa. But kuna shares in an increase, and then the dividend will not be what? Be paid. Sawa sawa. So from our case, of all the 112 shares that paid dividend, and the dividend paid tunaona ndo hii zote zinafaa kuwa ngapi? 112. Sawa sawa. Then tunaambiwa 78 shares had no what? Increase in price. Dividend ililipwa, lakini shares hazikufanya nini? Haziku increase. So meaning that we can get the one that increase the share prices, which in that case it will be how much? 112 minus 78? Yes? 34. So we go to the other information. Of all the 127 shares that had no price increase, though easy, they are how much? 100 and what? 27. 127. Tunaambiwa 49 shares did not pay what? So 49 hazikulipa, meaning that if I take the total of that, I'm supposed to get the what? That one. Sindio? Sindio tunaambiwa, si hapa hakuna no dividend pay. So in that case tunaambiwa, out of that the one that had no share increase in price, out the 49 shares had no what? Did not pay what? And no dividend, unaona ni ngapi? 49. Sawa sawa. And then the total number of shares is 200 and what? The total number of shares is 246. Sindio? Manisha, now we can fill in the values. Manisha tunaweza jua hii. Sindio? It is 246 minus 127 tujue the one that had increase in prices. Which is how much? Yes? 119. Sawa. These are the one that had no, they had increase in shares, and both the dividend maybe ilikuwa imelipwa na ama ilikuwa imelipwa. Sawa. So tunaweza pata yenye dividend haikulipwa lakini the shares increase in prices. So it is 119 minus what? 34. Itakupea ngapi? 20? Yes? 85. So 85 plus 49, you get the one that had no dividend pay. 130? 135? 4. And that is what we call a contingent what? Contingency table. Sawa. Then we can now answer the questions in Roman what? Roman 1. And beware the shares paid dividend, a share paid dividend. So when you check on the shares that paid dividend were of how much? Dividend paid. Yes. A per share dividend in that case is 112 minus, you divide by what? Sindio? They have not specified whether they increase in shares or no increase in shares. So in that case, it will be 112 246. Then Roman 2. A selected share neither pay dividend nor increase in what? Prices. No, neither pay dividend nor increase in price. Hakuna dividend ililipwa, ndio hiyo, si ndio? Si ndio, no dividend paid. But in this, no increase in what? Price. Si hapa kuna increase. Kumaanisha ni gani? 49. So in that case, neither dividend paid nor increase in shares, increase in price, which in that case itakuwa ngapi? Just 49 over 246. Then the second or last, a selected share paid dividend given that it had increased in what? Price. So in this case, Roman number 3, the dividend, that share, the share paid dividend, which in this case no easy, but in that case Nambiwa, there was increase in what? That had an increase in price of how much? So in that case, itakuja ngapi? They paid dividend, lakini ilikuwa increase in what? Shares, which is on what? The increase, sindio? So in that case, itakuja ngapi? Paid dividend given increase in what? In price. Alilipa dividend na pia kulikuwa na increase in price, which in that case itakuwa that you want. See on the increase in price. So it is 34 over 119. And then the last one, a selected share either increase in price or paid dividends or both. So in this case, either increase price probability, either price increase or in that case, there was also payment of what? Dividend. This is whereby we said when you are given this one, you use the addition what? Rule. So for the increase in price in this case is how much? 100 and what? 19 over 246. And then also on the payment of dividends, on the payment of dividend is 100 and what? 112, you divide by 246, which in that case is giving you how much? Increase in price and also what? The dividend payments, which in that case is giving you how much? Napata ngapi? When you check 119 plus 112, 119 plus 112, that case is 200 and what? 231. That is over 246. That is how you require to do on the same. So with that, these are the questions that you do as assignments. You will do November 2015. November 2015 question 2B. You'll also do these are the question of November 2016. November 2016 question 5A. November 2016 question 5A. And the last one you'll also do May 2017 question 1B. May 2017 question 1B. And therefore, we'll now be able to continue from there in our next class. We'll continue from there in our next class.